The two things we're going to cover in today's lesson are finding slope of a line from coordinate pairs, and then later we're going to talk about how to graph a line by making an XY chart or making a table. All right, so first we're going to find a slope a slope of a line from two coordinate pairs. So if you look down at example 4, you're going to see two sets of parentheses with two numbers in each parenthesis. That means you have an x and a y value in each of those parentheses. And so what we're going to do to calculate the slope from those two ordered pairs is we're going to subtract the y's on top and we're going to subtract the x's on the bottom. And so that's exactly what you're seeing in the formula in the box. Notice it says you can do y2 minus y1 over x2 minus x1, or actually it's okay to do y1 minus y2 over x1 minus x2. The important thing is that you have the y's on top and the x's on the bottom. And when we do example 4a, I'm going to show you what I mean by it's okay to do it in either order, all right? So let's get down to the examples and actually use the slope formula. So again, subtract your y's on top and your x's on the bottom. And so if you want to call this first pair x1 and y1 and the second pair x2 and y2, always remember that each parenthesis contains an x and a y. So our slope formula says subtract the y's on top. So we can go y2 minus y1, which would be 2 minus a negative 2, and then subtract your x's on the bottom. So since you started with the second ordered pair on the top, that's where you're going to start on the bottom. You're going to go back to that second ordered pair and start with x2, which is a negative 1, minus x1, which is 4. Now, as you can imagine, there's lots of sign mistakes that can happen on problems like this. So be careful with your signs or use your calculator so that you don't make sign mistakes. So what's happening on the top is a 2 minus a negative 2. Double negatives in math mean positive, so we really have a 4 on top. On the bottom, we have a negative 1 minus 4. Remember what happens when you have two negative numbers. You're really just adding them up and keeping it negative, so that would be a negative 5. And then we talked about the minus sign. In this problem, the minus ended up showing by the 5 in the denominator, but remember what an answer key is going to look like. They're going to stick that minus right in front of the fraction bar, and they're just going to show it as a negative 4/5. And that's because the negative, all it's really trying to tell you is that your line would be heading downhill. So if you leave the negative in front of the 5, I'm okay with that. I'm not going to mark anything wrong. But like I said, the answer key is going to show this as negative 4/5 with the negative in front of the fraction bar. So I told you I'm going to do this one two different ways. So I don't know why, but I'm going to switch colors here. And if we do this one a second way, meaning look up at that formula again and notice what I said. You could have done y2 minus y1, y1 minus y2 over x1 minus x2. You actually would have gotten the same answer. So let's do that just on this first one. If we do y1 minus y2, we're going to have m equals negative 2 minus 2 on the top. And then if we do x1 minus x2, we're going to get 4 minus a negative 1. If we simplify that, again, the top's going to become negative 4 because we have two negative numbers, and the bottom is going to become a positive 5 because whenever you have double negatives, they make positives. And in this case, the negative ended up in front of the 4 instead of in front of the 5. But remember, the answer key is just going to stick it next to the fraction bar because all the negative is telling us is that the line is heading downhill. So no matter which way you subtract them, you should get an answer of negative 4/5. So that's what we meant up above, that it really doesn't matter. But what I did write underneath that was subtract your x values in the same order that you subtracted your y values. So that means, notice how in each formula, let me erase some of this that I got going on here. In each formula, I started the same way on the bottom and the top. So like in the first one, I started with the y2 on both on the top, so I had to start with x2 on the bottom. And then if I'm going to switch the way I do it, I started with y1 on the top, so I had to start with x1 on the bottom. So that's what I mean by that highlighted statement there. All right, let's do a few more just so we get good at it. And we're not going to do them two different ways. I'm just going to stick with taking y2 minus y1 over x2 minus x1. We'll just stick with that way because that's typically, if you've seen this before, that's typically the way other teachers teach it. All right, so our slope is, if we subtract our y's on the top, we're going to go 3 minus 1. And then if we subtract our x's on the bottom, we'll do 4 minus 2. When we clean that up and simplify it, we get m equals 2 over 2. And 2 over 2 should be actually reduced. Remember, never leave a fraction unsimplified. So it reduces down to a 1. All right, if we go to C, again, remember to keep your y's subtracted on the top. We'll go 3 minus 0. And your x's are 2 minus 2. If we clean this up a bit, we ended up with 3 on the top because 3 minus 0 is 3, and 2 minus 2 is a 0. That's a no-no in math. You are not allowed to divide by 0. So our actual final answer is our slope is undefined. And if you leave your answer as 3 over 0, I'm going to actually take off half a point because that doesn't really help me to understand if you really realize that this is undefined. And undefined means we have a vertical line. So that's why it's important that you say it's undefined. All right, and finally D. Again, we'll subtract the y's on the top. So we'll do 5 minus 5. And then we'll subtract the x's on the bottom. Negative 4 minus 3. We end up getting m equals a 0 on the top, a negative 7 on the bottom. But a 0 divided by anything remains a 0. So your final answer is m equals 0. And again, if you leave it as 0 over negative 7, I'm going to take off a half a point because you didn't simplify your fraction. So this is the spot where a lot of people get confused. They mix up the word undefined and 0. So one way to remember it is to remember that it is a no-no, N-O, to have a 0 on the bottom. That's what makes it undefined. And it is absolutely okay to have a 0 on the top. That's what makes it 0. So it might be a little trick that helps you remember which one's undefined and which one is just a 0. Hopefully that helps. All right, so as you can imagine, using the slope formula, there are oftentimes sign mistakes, so be careful with your signs. The other mistake I see is sometimes people accidentally put the x's on the top. Make sure your y's are on the top. Remember, we're thinking of it as rise over run. Slope is always thought of as rise over run. And the final mistake that I sometimes see is that I think people just like crisscross things sometimes. Sometimes they'll use the 3. Oops, didn't mean to do it that way. Hold on a sec. They'll use the 3, and then all of a sudden they'll subtract the 2 from it. So remember, y's belong with y's on the top and x belong with x's on the bottom. So make sure you never subtract an x and a y. We shouldn't mix and match them. And those are just some of the things I see. Okay? All right, so that was one topic that we covered today. A second topic that we covered was graphing by using a table. And we sometimes call it an XY chart or a table. So, let me say X, comma, or X/Y chart. That's another way of saying a table. So you're going to see a bunch of steps. There's 6 steps in that box that tell you what to do. The important thing to do is, of course, to always solve for Y. We're going to sometimes make a table with 3 columns. You're going to see in the first example, we're not going to make 3 columns. We're only going to make 2. But everything else will probably make 3 columns. Well, that's not true. Sorry, there's some special cases at the end where we don't make 3 columns. But the typical case will use 3 columns, and you'll see some exceptions, as I just stated. All right, you're going to pick 3 different points for your x value. Your x value is what's called your independent variable. And it can be whatever it wants usually. There's, again, a couple special cases that we'll see at the end of these notes, but this is typically our independent variable. So you can pick really whatever you want, but I'm going to suggest that you pick a negative number, 0, and a positive number. But like you can see, I said they're good choices. They're not the only choices. So if you pick something different, you will still get full credit. Number 4, you're going to use the equation to find your y value. And now you will have coordinates of a point. You'll have xy coordinates that you can plot. You're going to plot your 3 points, and then you're going to draw a line. Make sure, you can see it here, make sure you have arrowheads at each end because we are drawing a line that goes on forever and ever. So if you don't draw your arrowheads, I'll take off a half a point, okay? And if your points do not line up, then you need to recheck your calculations. You did something wrong. Because everything we're giving you is a linear equation, which means if you graph it correctly, if you calculate things correctly, there will be a line when you're done. All right, so example 1. Like I said, we really don't need 3 columns for this chart. What this is trying to tell us that y and x are the same, right? So I said the independent variable is x. It can be whatever it wants. So we typically pick a negative number, and I usually just keep it small. And definitely it has to fit on your graph. So you can see over on the side there, you have what's called a 10 by 10 graph because it goes 10 in every direction. So you definitely don't want to pick something like a 20 for your x because it doesn't even fit on your graph. But I typically just pick a very small negative number like -1. I pick a 0, and then I pick a +1. And what our equation is saying here, it's saying that y is the same thing as x. And I forgot to mention it up above, but y is what's called our dependent variable. In most cases, it depends on what you pick for x. Again, there's a couple exceptions that we'll see at the end of the notes, but in most cases, y depends on what you plugged in for x. All right, so if I'm plugging in -1 for x, my y is going to be equal to that because that's what the equation says, right? Y is equal to x. So if x is -1, then so is y. If x is 0, then so is y. If x is 1, then so is y. So that's exactly what y equals x means, that they're both going to have the same value. All right, we're going to plot those 3 points. Now in my Marsland class, I make them add another column and I make them do the XY pair. I make them state it. I usually don't make academic kids do that, but the XY pair would be -1, -1, 0, 0, and 1, 1. And you're going to see I'm not going to do this on the rest of the examples. I'm not going to add that column because, like I said, normally academic kids can understand how to plot the points without actually rewriting them as an ordered pair. But if we plot those, we're going to go -1, -1, which is going to be down here. We're going to go 0, 0, which is at our origin. And we're going to go 1, 1, which is up there in that first quadrant. If we connect the dots, sometimes hard to do with a straight line, but there we go. Make a straight line. And please don't forget your arrowheads because, like I said, I will take off half a point if you don't have your arrowheads. All right, so there we are. We graphed our first line. Let's try it again with something a little more complicated than that. So for number 2, we are going to make those 3 columns. And the 3 columns will have x values. The next column will have 2x minus 4. And the third column, we realize that's how we're getting y. That's 2x minus 4 is equal to y. Pick your 3 values. Again, pick small numbers so you make sure it all fits on the graph. So I just typically pick -1, 0, and 1. And then in the middle column, I like to show what's happening there. We're having 2 times -1 minus 4. If you're good with math, arithmetic, then please do this in your head. If you're not, please use a calculator. There's no sense getting it wrong if you're bad with your multiplication and your positives and your negatives. So this would give you 2 times -1 is -2, -2 minus 4 is -6. If we plug in a 0, we'll have 2 times 0 minus 4. Well, 2 times 0 is 0. 0 minus 4 is -4. And then we'll have 2 times 1 minus 4. If we do that, we get 2 minus 4 is -2. So my 3 ordered pairs are -1, -6. Oops, let's plot that one first. 0, -4. Plot that one second. And 1, -2. Plot that one third. They all line up in a nice straight line. If they didn't, it would mean I made a mistake, right? It would mean I'd have to go back and check my calculations. But they do end up in a nice straight line, and I will put arrowheads on the end. Another thing I said in class today was if we are taking a paper and pencil test and you want to make sure your lines are nice and straight, you should use your ID, your photo ID as a nice straight edge. All right, number 3 really is almost the same as number 2, but let's do it anyway. In class, everybody did this together or did this one on their own. But so again, you get to pick x values. To calculate y, you're going to do -3x plus 1. That's how you're going to get your y. So if I pick again that -1, 0, and 1, and I actually show how that looks when it's plugged in, -3 times -1 plus 1 is how I'm getting my first y value, and that will give me 4. My next y value will be found by taking -3 times 0 plus 1, and when I do all that math, I get a positive 1. And then finally, my third y value will be gotten from -3 times 1 plus 1, and that will give me -2. If I plot those points, it'd be -1, 4, so -1, 4 is up here. 0, 1, that's on my y-axis. And then 1, -2 is down here in that fourth quadrant. If we connect the dots, that's what our line looks like. Heading downhill, it's a negative slope. All right, so let's throw a little bit of a twist in there. On number 4, you're going to notice that y is not isolated. And if you went back up to the first step here, it says solve for y. And so far, y has already been solved for. Y is already isolated. Once we get to number 4, we have to solve for y. And so since we're subtracting x from the y, we're going to add x so we can move it off to the other side. And now we will have an isolated y. On the other side of the equal sign, make sure to write your variable first. Let's write our x first. It's just a positive x, so we can just write x. And we have a positive 3, so we'll write our constant second. And now we can make our table. Our x, again, can be -1, 0, and 1. Our y is going to be found by taking our x value and adding 3. That's how we're going to find our y. And so show the plug-in step. -1 plus 3 equals 2. 0 plus 3 equals 3. And 1 plus 3 equals 4. So I'm just plugging in the values that I had chosen for x. And again, remember, it doesn't matter what you pick for x. You could pick different values, but we're keeping it nice and small so we make sure it fits on the graph. Then the math should be very easy. There's good reasons for picking small numbers, but if you want to pick a couple of numbers that are a little bit bigger, as long as they fit on the graph, then that's fine. You'll get full credit. All right, so my 3 ordered pairs are -1, 2, 0, 3, and 1, 4. So those are all real nice and close to each other, and we'll put our straight line through them with our arrowheads. All right, number 5 has a little bit of a twist to it. First of all, of course, we do have to isolate the y, so we're going to subtract 6x from both sides. And what we have is, again, it'll cancel off of the left side. We have 2y equals, write your x value first, -6x, write your constant second, which is a positive 4. We don't have an isolated y yet. We've got to divide by 2. And then it means we have to divide everything by 2 on the other side. So we end up getting y equals -3x plus 2. All right, now we have an isolated y, and we can pick our x's of -1, 0, and 1. We can write our equation in the middle because we know that's how we're getting our y. So -3 times -1 plus 2, I'm just plugging in my x values that I chose, right? Remember, it's independent. It could be what it wants. That gives me a y value of 5. -3 times 0 plus 2 gives me a 2. -3 times 1 plus 2 gives me -1. So if we plot those, -1, 5 would be up here. 0, 2 would be right on our y-axis, and -1 would be down there in that fourth quadrant again. All right, so hopefully by now you're going, oh my goodness, I get it. But I have to show you a couple more because there's a few things that haven't happened yet. So the last 3 will be special. So in number 6, let's isolate our y by subtracting x. And we'll get 2y equals -x plus 2. Then we have to divide by 2. We're dividing everything on the other side by 2. And we end up getting y equals, well, think about what's happening in this term right here that I've just highlighted in green. There's really an invisible -1 in front of our x. So that's like saying we have negative 1/2 x plus, and 2 over 2 is 1. All right, now that our y is isolated, we can pick whatever we want for x, but this one's special. If we pick negative 1, 0, and 1, think about what's going to happen. Let's write our equation in here. Negative 1/2 x plus 1 equals our y. What's going to happen here is we're going to get a fraction, and we don't want fractions. If we plug this in, which I'm going to erase in a minute because I don't want a fraction. If we plug in a negative 1 next to that negative 1/2, it turns it into a positive 1/2 plus 1. Positive 1/2 plus 1 is 1.5 or 3/2. I don't want to plot fractions on my coordinate plane. In fact, the directions on the next quiz are going to say, do not plot fractions, only plot integers. So we cannot pick negative 1, 0, and 1. That's not going to be the right thing to pick. What you want to pick is whatever the denominator is what you want to pick. So since that denominator is a 2, I'm going to pick a negative 2 and a positive 2 for sure. But I'm also going to still pick that 0. Think about why I would do that. If you stick a negative 2 next to a negative 1/2, those two 2's will end up canceling and becoming invisible 1's. The thing you do have to watch out for, though, is you have a double negative happening there. So we will have a positive 1 there plus another 1 equals 2. And I definitely suggest using the calculator if you don't know how to manage your fractions, okay? Now think what happens if we plug in a 0 next to that negative 1/2. This will just cancel and become a 0. So we have 0 plus 1 is 1. And then if we have negative 1/2 times the regular 2, the positive 2, again, these 2's are going to cancel. And one's positive, one's negative. So we end up, remember again, when they cancel, they become 1's. So we have a negative 1 times a positive 1. That stays as a negative 1. So we have negative 1 plus this 1 here. That makes 0. And during class, I lost a few people on that. So we yanked out our calculators and I showed everybody how to do it on a calculator. So I can definitely show anybody the calculator again if you're still confused. All right, so our points are negative 2, positive 2, 0, 1, and 2, 0. So we're plotting our points and connecting the dots and drawing in our line. So on this one, if you ever end up with a fraction in front of your x, you have to pick numbers that will help to clear that fraction. And that means the number that's in the denominator should be picked, or if you had wanted, you could pick any number that can be divisible by 2. But again, you're trying to keep it on the graph. So if you wanted to pick something like a 4 and a negative 4, that would work. You could have done that too. All right, the last two look very strange. So if we look at 7 and 8 together, you're going to notice that in number 7, there's only one variable. There's just an x. And in number 8, there's only one variable. There's just a y. And so those are not like these that we've done up above. Every problem we've done so far had an x and a y. So these are special. And what's happening here is we have a special case of either a horizontal line or a vertical line. So those are our two special cases, are the horizontal line and the vertical line. So if we looked at number 7, and I'm not even going to bother making a table. Well, you could make a table. I don't expect you to, though. So let's talk about what the table would look like if you wanted to make one. Remember, you can pick whatever you want for x typically. But it's saying x is always 4. That's what this is saying here. X equals 4. 4 is a constant. There is no y value. So it's telling you no matter what, x has to be 4. So really, you can't pick whatever you want. You would have to pick 4. You'd have to pick 4. You'd always have to pick 4. So to me, the table really doesn't make a lot of sense. What I think you should notice is this one's weird because it only has one variable. And they're telling you that the x value on your line has to always be 4. That's a vertical line. If you draw a vertical line straight through the x value of 4, any point on this line, doesn't matter what point you put on this line, it has an x value of 4. It has different y values, different heights, but it's constantly at that x value of 4. So you're going to need to recognize that if a variable is missing and you only have an x, that's going to be a vertical line. So conversely, number 8, the x is missing, so that's going to be our horizontal line. So our horizontal line is happening right at 4. And think about again what this is saying. Your y is a constant of 4. It's always, always, always 4 because there's no x. It doesn't really matter what x is. Y is going to stay 4. So it doesn't depend on x anymore. So our y value is constantly at 4 if we draw a horizontal line right up at the 4. So those are the 2 special cases that do not need a table. Hopefully they stick out like a sore thumb because you see they're missing one of the variables. All right, and that's what we covered today.